Good morning, good afternoon, wherever you are. My name is Paul Simmonds. We're going to be talking this afternoon about flawed identity models and why they perpetuate insecure computing. And the big culprit here is the human-centric identity model, which is what we're going to be talking about. So a very simple agenda, hopefully. How did we get this all wrong? Viewing differently, how we separate human and non-human identities, and why if we do this, we're probably doomed to fail, and some principles for building a better identity ecosystem. Let's kick off. Mankind has always looked up at the sky and tried to make sense of what they saw, and designed a model based upon the human at the centre of those observations. And, after all, our perception is our reality, as they say. And every time the tech improved, better telescopes, better measurements, everything else, the model had to be kludged just a little bit more, and we ended up with this thing. This is the human-centric view of the solar system. And in 1515, a guy called Nicholas Copernicus came across. He stood back from the problem and proposed that all planets circled the sun, destroying thousands of years of flawed thinking and kludges to try and make an Earth or a person-centric solution fit. So how does that relate to computing? Well, we need to go back for a little bit of history first. In 1943, Thomas Watson, the then president of IBM, is famous for saying, "I think there is a world market for maybe 5 computers." We've got a few more than that. But if you're old enough to remember when your business got its first mainframe, you had just one. There were no concepts of bidirectional trust, risk, contextual-based access, machine identity, or even, of course, the internet. All we needed to do was to authenticate the user to a green screen connected to the mainframe on a dedicated terminal line. And the trouble is, this model has infected our thinking ever since. Along came the mini computer, and with the advent of multiple mini computers, we hit the how do I keep multiple user accounts in sync? Guess what? We dedicated a single computer to do it all at once for all the systems that we put in. And ultimately, this is what we call the locus of control problem. It's the give it all to me and I can make it all work seamlessly. Or in this case, manage everything in one central system. But of course, it's still that original model. It's still binary authentication based on a one-way trust. Then along came networking, and with that we had things like AppleTalk, we had Ethernet, that's thick Ethernet for those of you not young enough to remember it. We had Windows, we had the advent of networking with things like Novell, and finally what people know and love today, some form of Active Directory. And we had multiple disparate systems, we had hardware, we had local area networks, WANs hadn't arrived at that point, and at that point, the central locus of control model started to break down. But hey-ho, no need to revisit the model. We just kludged some interfaces between them. And after all, it was a LAN. We were all trusted staff. We were all in the same physical building. And we knew each other. So what is there to worry about? And then everything broke. We had a private WAN connection to other offices where, of course, we didn't necessarily know the users. And then we connected to this thing called the internet. But by then, of course, the concept of users and user identity was deeply ingrained into our collective security psyche. And we implemented corporate policies at that time like, well, everything must use AD. If they were contractors, we enrolled them with a dummy staff user ID, and the same for partners and third parties all needing access. And we gave out secure ID tokens like Sweeties so that anyone who needed it could have remote VPN access. And we created this thing that we sort of talk about called the vicious IAM cycle. And it looks like this, is I have a single IAM system. And, typically you would call that AD. It might have been something else, but for most people it was Windows and AD. And therefore, my access control system, my PDP, my PEP, which is what we call them these days, only links to my IAM system. Thus, all people requiring access must be in my IAM system. And finally, all systems therefore need to talk to my IAM system, and therefore I have to have a single IAM system. And we go round this vicious cycle time and time again, which is why we had policies like everything must use AD. And it was fine as long as you were the big player in the third-party arrangements. So, if you were a large corporate, you could dictate to your smaller partners, you will use our identity and access management system. But of course, if you weren't, then you were obliged to use someone else's and fall into their system. And it was all to do with users. So what's the conclusion? Well, you're probably sitting there thinking, well, he would say that, wouldn't he? Hindsight is always 2020. And I'm going to argue that, however, at this point back in time, the early 2000s, we probably should have stood back, re-evaluated the user-centric model, talked about risk, access, context, data, authentication, entities, not users, and attributes. And just to blow our own trumpet, actually we did. And we talked about all these things, but 20 years on, guess what? Our entire computer ecosystem is still based on the fundamental concepts around the authentication of human users. So that's your history for you. We need to sort of turn around and say, well, in this day and age, we need to view it slightly differently. So let's have a look at it. So here is what I call Identity 1.0. Identity 1.0, or the good old username and password, is predicated on unidirectional risk and evaluation. And it's actually just proving to the computer that you are actually you, called authentication. And passing authentication leads to a flawed binary assumption that you actually are the user. There's no risk, there's no nothing else. If you know the username and password, you get in. And we falsely call this user identity, but it's not. It's user authentication. And ultimately, it's all about just proving that the user is Joe User, and then applying a whole bunch of access controls to that. Here's Identity 2.0. We kludge or adapt our flawed user-centric model into third-party cloud and other systems that have come along. And to do that, we use not quite a roll of this, but it's pretty close to that. We use things like single sign-on, except there is no such thing as single sign-on. At best, it's reduced sign-on. We use, we've invented standards like SAML, OAuth, SCIM, UMA, and of course, hot off the press, Spiffy and Spire. And we glue together those disparate identity silos that we have, either our ones, someone else's ones in the cloud. We federate identities, although that is horribly flawed. Or we buy into someone else's identity management system, whether it's Google, Facebook, Microsoft, or anything else. And again, 90% of the standards and solutions are based around user authentication and rely on the need to provision all identities somewhere, whether they're in your system or they're in someone else's system. And the problem is that this is what it actually looks like, or we end up delivering to our businesses. Yeah, need to provision all identities, and generally in most businesses, I have to say, it ends up as quite a real mess and a kludge, because we continue to add more and more services, more and more disparate services around things. So let's go back and look at what actually identity really is. So identity is a collection of attributes linked to an entity, hopefully signed by the authoritative source for each attribute, which, when asserted, allows the recipient to determine the likelihood of the entity or device, system, workload, or user taking the assertion and is linked to the actual entity. So thus, this should allow you to make a risk-based decision about whether to transact. Now, bear in mind, this should be, in an ideal world, a bidirectional transaction of trusted attributes. The usual, hey, wait a second, you are claiming to be my bank phone call, can you prove it, exists in this space as well. And quite often you can't. Computers based on that Identity 1.0 is all about authenticating to the computer. God with a small g. If you're lucky enough, you get an account. And ultimately, you need to note that doing it differently in this context means having no differentiation, in principle, between human and non-human identities. There's going to be a practical difference because of the need to connect what we call the wetware to the hardware. In other words, the person to the device. What are entities, and what are human and non-human? And I'm going to argue with you today that human and non-human identities should more correctly just be called entities. So in a global identity ecosystem, identity needs to work identically and interchangeably across all the entity types. So we have people, we know about those. We have devices. We have organizations, we have code, we have agents, and actually everything else besides, because identity also applies to things like containers, to workloads, and much, much more. Yeah, the definition of an entity is, as it says there, a unique thing with distinct and independent existence. And ultimately, key to this is that the digital join between two entities gives us context. So if you think about it, the join between entity person, human me, and entity IoT device light bulb makes it my light bulb. But actually, this is an identity 1.0 way of thinking. More realistically, the join between an entity, IoT light bulb, and entity house makes it the house's light bulb, with the rule anyone in the house can send a controller session, rather than it's an app on my phone that only I can control, which again is that flawed identity 1.0 way of thinking. And in business, we need to think differently. So we already have multiple disparate glue solutions trying to keep everything in sync. You might have been lucky enough to get it down to one product that rules everything in your organization, but I will lay you odds that actually what's going on inside your organization is you've probably got about 70 or 80% of stuff joined up with some kind of synchronization tool, glue identity tool, but actually there's probably at least 30% that you're doing specials for. And of course, then we add all those other entities, both human and non-human, that need to come in to our businesses. So if you look at them, third parties, contractors, partners, divestments, federation, customers, all of those bits and pieces that need to come in and connect to your business. APIs would be another one. And ultimately, what we end up doing is we end up putting a special kludge in for each of those connections with special sort of processes to onboard them and offboard them. And of course, we usually do a reasonably good job of onboarding them. We usually do a really bad job of offboarding them. And as you'll know, the standing joke in this industry is that we do a really good job with staff on payroll, and everything else, actually, when you come to an external or an internal audit, the IT department gets dinged because there's loads of things that still have permissions left on the system that no one has told the IT department about that we've stopped doing. And whether that's contractors who have left or APIs we're not using anymore or whatever. And ultimately, as we all know, I don't need to quote any of the press headlines at you, this model leaves plenty of cracks for the bad guys to happily slip through and make mischief inside our businesses. So if that was identity 1 and identity 2, what does identity 3 look like? To do this, I'm going to give you a very trivial worked example of what identity 1, 2 and 3 may look like. So here we are. I want to buy a bottle of whiskey. Simple as that. And in real life, IRL, we do this. Yeah. I'm in the UK, so therefore the law says you need to be over 18 to buy a bottle of whiskey, obviously 21 in the States. If I walk into an off license, we do some visual checks. They look at me and go, yeah, grey hair, he's definitely over 18. I hand over a £20 note, and there are a bunch of visual checks that shops can do to check, and actually British £20 notes have a UV light function behind them, so you can put them out. If you're not sure, you put them under the UV light to check it's really genuine. And I take receipt of the bottle. It's handed over to the person who stood there, who's over 18, with the money. Nice and simple, hopefully. And context is provided by being physically present. And, of course, it's anonymous and privacy protecting as much as it can be in the modern surveillance society. So, if that's buying it in real life, let's look at what we do today with current systems. So here's my purchase over the internet. First of all, it's a restricted transaction. Yeah, it goes under license to operate from the organization that is actually going to sell you the bottle of whiskey. So first of all, we ask the person to create an account on a UK system. We require them to enter their age, not the fact they're over 18. We require generally age, and we store the attribute in that account. And then we require them to enter a delivery address, and we store that in the account, and then we ask for card payment details, and we might ask them to store that as well, or ask for it on a one-off basis. And I order a bottle of whiskey, and you deliver it. And sometimes, not often, whoever comes to the door of the courier actually has a note on the parcel that says, this needs to be signed by someone who is over 18. Not the person who ordered it, just someone who is over 18. So what are the problems with this? Well, the first one is there's little anonymity or privacy. There's a need to create an account, even if it's a guest account. Again, we're doing the binary password error. So username and password means that actually it could be my 15-year-old son or daughter who happens to know my password, or it could be a hacker, or it could, of course, these days be an AI. And there's little linkage between the device used, the person, the money, and the delivery address. It's all pretty disconnected. And there's an assumption the delivery address is actually genuine, that what I entered was actually there. And if we're lucky, there are some background checks going on, and both with the device, there's some anti-fraud on the location, there's some IP address checking, some credit card checking, etc., etc. And okay, it's a trivial example with a bottle of whiskey, but this could be a trial run before ordering a high-value item. And ultimately, this is why the bad guys are winning. And again, the root cause of this failing is the fixation with the need for a user account. Can we do this better? Well, I'm going to argue with you, yes, we can. What does Identity 3 look like in this environment? So, first of all, we need a bunch of authoritative sources. So we're going to use an Android for this example. So we have Android and Google as the authoritative source for the device. We have the UK government as the authoritative source for dates of birth, because I'm in the UK. We have Visa as my chosen method of payment. And we got the Royal Mail, who know where I live. And it looks something like this. So the Android and Google provide, or the maker provides the security attributes that go with the phone to tell me it hasn't been hacked and it's reasonably secure. The join between me and UK government gives me an assertable attribute that I am over 18, not my date of birth. Visa gives me a one-time payment on the ability to pay, and Royal Mail knows where I live, so it goes to a genuine address. All that is missing from this picture is this thing, what we call the level of immutable linkage. In other words, how well am I connected to the device I am using? So let's say, for example, the known level of linkage in this case is fingerprint unlocked in the last 5 minutes. And all of this information, along with the device status, the person attributes of over 18, payment and delivery address, are sent to the vendor, all tied together with a nice cryptographic bow. And what that means is that the vendor can ship the whiskey in the knowledge that only one entity could have asserted all the attributes in a cryptographically linked set with a known level of certainty that meets the vendor's risk tolerance in this case. And finally, is it privacy enhancing? Well, it is a little bit, because we're not being asked to give our date of birth over. But if I really want to make this transaction anonymous and privacy enhancing, I could substitute Visa for Bitcoin, and I could substitute the Royal Mail for a Dropbox service. On to 3. If we separate human and non-human entities, we are doomed to fail, which, for a seminar series on non-human identities, seems a bit of an oxymoron, but bear with me. So why are entities so important? Because in reality, over a network, you can't easily distinguish humans from any other entity type. In reality, you do not know binary 1, whether it's a person, an AI, an IoT device, a system, or a hacker at the end of the conversation. And of course, going forwards, it's only getting worse. So it's a bit like a modern day Turing test. Not only are we trying to determine whether it's a particular type of entity, we're also trying to determine that the credentials match the actual entity claimed. So just because the password or the certificate matches, or even if the API says it's a biometric match, it still does not make it 100% the entity claimed. And this is really important, that we should never be turning a probability. We think with a high degree of certainty it's Paul Simmonds, but we should never ever be turning that into a binary and passing that on. So when communicating, we should care about the fidelity of the entity's assertions of who or what they claim to be, and the level of immutability between the entity and the claim. So I'm going to refer you back to this slide that I showed you earlier. So all entities have identity and attributes, not just people. And just to make this clear, we assert attributes of our overall identity. We do not assert our identity. And because we come from an industry that's fixated on user authentication, then while it's convenient to talk about non-human identity and remind people that there are all those extra entities to take into consideration, this does not in any way imply that we need two ecosystems, one for humans and one for non-humans, or even actually subsections of non-humans. I'm going to leave you with 5 principles for building a better ecosystem. So here's the first one. We need to stop thinking about binary access decisions, but instead of this thing called entitlement. So are you entitled to have access? So what is that? It's about making, and it's the only slide I'll read out verbatim, it's about making a contextual, risk-based decision about access to data and or systems based on the trusted attributes offered by all the entities and components in the transaction chain. In other words, the better we can understand that whole transaction chain and everyone involved or everything involved with it, the better we can make a risk-based decision. And as a blatant plug, this is the reason that the CSA Zero Trust Identity Working Group produced this document, because this is really important when you get onto doing things like zero trust, that you actually use context-based access control for a zero trust environment. So context is key. We need to be able to consume and analyze attributes as a set, because otherwise we end up trying to glue together disparate identity sources together. And we all know that complexity ultimately is the enemy of good security. So can we make it as simple as possible? Can we evaluate attributes from disparate sources and disparate organizations in one system such that we can make a better risk-based decision? Second, words like authentication tend to imply binary authentication via an identity store. And if you go back and remember what I defined the locus of control problem, which is you all play in my identity and access management system and I can make it all work for you. The trouble is that does not scale. So we need to think about how authentication, by whatever method and however tenuous, is the key to sameness. The method by which any entity, human or non-human, is unique in our eyes or a system's eyes to a known degree of confidence. And remember, sameness could be an IP address of a system or a MAC address or an email address, all of which are theoretically unique. And they might be okay for low integrity sameness, but they are not probably okay for a high value, high risk transaction. Third, it's important to understand as part of your risk calculations with what degree of certainty the actual entity is linked to the identifier that you're using for sameness. In the human world, and we like to use human examples as humans because people understand them better, I look enough like my brother, who's 2 years younger than I am, that if you have not seen us for 10 years, it's not unusual for friends, especially friends of my parents who we meet once in a blue moon, to get us wrong and call me David and David Paul when they meet just one of us. But I suspect they'll get it right if they meet both of us together. So it's really important. And, remember, immutable binding must never be binary. So you look at us and go, okay, the mutable binding is the face. And ultimately, you look at that and say, I'm pretty sure that's Paul, or I'm pretty sure that's David. And ditto, we can apply that into the non-human space as well. And the method used should always be understood by the entity taking the risk. In other words, communicate everything about how in the background you are doing that immutable binding, whether it's fingerprint in the last 5 minutes, whether it's an IP address. You need to pass all that information to the entity that is going to be taking the risk in the transaction. Remembering, of course, that transactions actually, from a risk point of view, are bidirectional or should be bidirectional, but are always asymmetric in some aspect. Fourth, when you're making an entitlement decision, the relying party needs to understand the degree of certainty with which the entity asserting an attribute is entitled to that attribute and the provenance of that attribute. So it might be signed by a government entity or it might be self-asserted. So while this is easier with non-human entities, with people this can be really difficult as it relies on understanding that level of binding, that level of immutability between entity person and entity device, or, as I joked earlier, the connection between the wetware and the firmware. And fifth, sometimes we won't care about the provenance of an attribute. So let's not go overboard when we don't need to. For example, an attribute of prefers to be known as with an attribute of Fred will probably be a self-asserted attribute and is authoritative, as the entity itself, who wants to be called Fred, will have set it. While, contrast that with legal name at birth, should be an asserted attribute signed, in my case, because I'm a UK citizen, by the UK government as they issued my birth certificate. And of course, in our worked example earlier for the bottle of whiskey, is over 18, to buy that bottle of whiskey should ideally be signed by a government entity of some kind. It'll vary, obviously, by country. So, those are the 5 principles, and I'll leave you with 5 blockers for you to consider, both for what you have at the moment and what you're building for the future. And hopefully these won't come as any surprise to you. The first one is fixation on the user. So rather than considering all entities as equal. Number 2, the ability to consume attributes we don't issue. And again, it's this locus of control problem. We need to have an environment where we can consume and hand out attributes for which we are authoritative and consume attributes from authoritative sources that we do not own or manage. Because maintaining attributes that go stale, whatever they are, whether they're users who have left or, I don't know, a right to work in the country, for example, if we maintain those, we are not authoritative for those, and therein lies ruin. We create a binary trust ecosystem. We constantly turn a maybe into an is. So we analyze and say, right, we're good to go, rather than passing on that information to whoever needs to make the risk-based decision. And ultimately, number 4, an inability to share attributes with other entities with risk and immutability information. And finally, an inability to understand attributes in context, because of course we silo our existing identity systems. So here's my final thought for you. This is the heliocentric model, going back to the very start. If you eliminate the human center fixation, stand back from the problem, suddenly it all becomes very simple. Ultimately, while the use of the term non-human identities may start the discussion, the solution, I'm going to argue with you today, lies in treating all entities identically. And with that, thank you very much.